Unit 1A, Lesson 4. This lesson would align with 7.5 in your textbooks. The standard we're going to focus on in this lesson is, given a geometric figure and a rotation, reflection, or translation, draw the transform figure using graph paper, tracing paper, or geometry software. And then we're going to specify a sequence of transformations that will carry a given figure onto another. In this first example, we want to graph the image of triangle EFG after a translation 4 units left and 2 units down. So we're just going to take each of these vertices and shift them the number of times it says to the left and down. So if we start with point F, we go 4 units to the left, 1, 2, 3, 4, and 2 units down. That new point is going to be F prime. Same thing with E. If we go 4 units left, 2 units down, this new point is going to be E prime. And the last one, G, 4 units left, 1, 2, 3, 4, 2 units down. That point is G prime. So now all we have to do is connect all these points. And we have our new transformed image after a translation 4 units left and 2 units down. In the second example, we want to graph the image of rectangle PQRS after a reflection across the line x equals 1. So the first thing I'm going to do is draw this line of reflection. X equals 1 is a vertical line that we can just give ourselves a reference point of where we're going to be reflecting across. So now that we have that, it doesn't matter which point we start with. I'm going to start with point R. We know the only thing that's going to change are the x values. The y values will not change. So R takes 1, 2, 3 units to get to this line of reflection. So we're going to be 3 units on the other side. Same thing with Q. So this is R prime, and this is Q prime. S is 1, 2, 3, 4, 5, 6, 7 units away. So 1, 2, 3, 4, 5, 6, 7, which means P prime will be here. So we have S prime and P prime. So we connect all the dots, and we have our reflected image of PQRS on the other side of the line x equals 1. Example 3, we want to graph the image of rhombus CDEF after a rotation 270 degrees counterclockwise around the origin. Previously in a lesson, I told you to write down a few different rules for reflections and rotations about the origin. This is going to come in handy now. Okay, so if we're going 270 degrees counterclockwise around the origin, our rule for x and y is that our y coordinate from our first point is going to actually become our x coordinate, and the x coordinate, we're going to make it the opposite, and that's going to be our new y coordinate. Alright, so if we're looking at point C, and we want to find C prime, the y coordinate of C, which is -8, becomes the x coordinate, so -8. Our original x value, which is -7, we're going to make that the opposite, so that'll be a +7, and that becomes the y coordinate. Okay, so for point D now, we want to look at the y value, which is -3, that becomes the x value. Now we have to look at the x value, which is -7, we make that the opposite, +7, that becomes the y value. Point E, look at the y value, it's 0, that becomes our x value. The x value, which is -3, make that the opposite, which is +3, that becomes our new y value for E prime. And the last point, F, we have a y value of -5, that becomes our new x value. Then we look at the x value, which is -3, make that the opposite, +3, and that's the new y value for F prime. So now we have all these points. We're going to plot all these points. C prime, we have -8, +7. That was C prime. Now we want to go to D prime, -3, +7. E prime 0, 3, so 0 up 3, and F prime negative 5 up 3. So I'll connect all these points. And that is our new shape, our new rhombus that is created after we take a rotation of 270 degrees counterclockwise. So those rules are going to become very useful if you wrote those down in your notes. Now we're going to discuss compositions of transformations. Compositions are two or more transformations that are combined to produce a single transformation. The most common one is a glide reflection. Glide is referring to a translation, so glide reflection, think of that as a translation and then a reflection. In a glide reflection, the order in which the transformations are performed does not affect the final image. For other compositions of transformations, say if we have rotations involved, the order may affect the final image. For the final example, we want to graph the image of the kite EFGH after the following transformation. So we're going to do a composition, we're going to have a translation, followed by a rotation. So the first transformation was the translation, where it was x plus 2, so 2 units to the right, and y plus 17, 17 units up. So I went ahead, plotted all those points, drew the new image, E prime, F prime, G prime, H prime. So now we're going to take this new image after the translation, and we're going to perform a rotation 180 degrees counterclockwise around the origin. The rule for a rotation 180 degrees counterclockwise around the origin is we're going to replace x, make it negative x, replace y, make it negative y. So the signs are just going to change. So if we look at E prime, 13, 8 is that ordered pair, we're going to make those the opposite. So I'm going to go negative 13 and then negative 8. And that point is going to be E double prime. We're just going to use two apostrophes for that. Now we're going to do the same thing with point F, negative 11, negative 12. That is F double prime. G prime, negative 5 and negative 8 is going to be our new point. G double prime. Now the last one, H prime is 11, 4, so negative 11, negative 4 will be H double prime. Now we connect the points. And now we have our composition of transformations, the translation x plus 2, y plus 17, and then a rotation 180 degrees counterclockwise. Now we have the kite E double prime, H double prime, G double prime, F double prime. In this lesson, we were able to perform translations, reflections, and rotations of a given shape to create the new image. You also learned what compositions of transformations were, two or more transformations combined into one to create one transformation. And we were able to perform that composition to discover the new shape that's created. Remember, if we have two transformations for the second one, we're just going to use a double prime to denote that final image.